We are going to solve items 1 and 2. First, we need to solve the mole of hydrogen. So for that, we will need water ionization constant, that is Kw, is equal to hydrogen times hydroxide. Now, the water ionization constant is 1 times 10 to the power of negative 14, and OH is already given, so times 10 to the power of negative 7. So what we want is that we will move it here, times 10 to the power of negative 14 times 10 to the power of negative 7. So we should get times 10 to the power of negative 14 on top, and on the bottom is times 10 to the power of negative 7. And we should get 1 times 10 to the power of negative 7. So that is 1 times 10 to the power of negative 7. To solve for pH is negative log of hydrogen. So negative log of hydrogen is 1 times 10 to the power of negative 7. So the power of hydrogen is negative log 10, 1 times 10 to the power of negative 7. That is 7. And now we can to solve power of hydroxide, we will also, since this is also given, we can also use this. So minus log is equal to so power of hydroxide is equal to 1 times 10 to the power of negative 7. So the value of POH, where negative log times 10 to the power of negative 7 is also 7. Now since pH and POH are both 7, the classification is neutral. And now for item 2. Okay, for item 2, only power of hydrogen is given. So first, let's find power of hydroxide. So pH plus POH is equal to 14, because 14 is the highest number in the pH scale. So since pH is given, we will input 4.50 plus POH is equal to 14. So it should be POH is equal to 14 minus 4.50. Therefore, POH is equal to 4.50, 9.5. So we put 9.5 here. So first we will get mole of hydrogen. So to get mole of hydrogen, pH is equal to negative log of 8 of hydrogen. So first we input 4.5 minus log is equal to H. This is tricky since we're dealing with logarithmic. So first we need to multiply both of these by minus sign, so that we get negative 4.50 is equal to log of h. So what we're going to do is we're going to get rid of log by transferring it here. But when we transfer here, it will become 10 to the power of 4.50 is equal to hydrogen, because this is logarithmic. So the mole of H the mole of hydrogen should be equal to shift log, we should get 10 to the power of negative 4.50, 3.16 times 10 to the power of negative 5. 3.16 times 10 to the power of negative 5. So now we can use the mole of hydrogen to get mole of hydroxide. So for that we can use Kw is equal to H plus OH. So just like before, 10 times 10 to the power of negative 14, this hydrogen is given, so we will find OH. So to find OH, we will put 1 times 10 to the power of negative 14 divided by 3.16 times 10 to the power of negative 5. So our value for the mole of OH should be 10 to the power of negative 14, 3.16 times 10 to the power of negative 5 should be 3.16 times 10 to the power of negative 10. 3.16 times 10 to the power of negative 10. So for here, since power of hydroxide is greater than the power of hydrogen, this is acidic. A bonus tip: we can actually find the value of hydroxide using the power of hydroxide. So POH is equal to minus log of OH. Just like before, we will input the power of OH, and just like before, we will get rid of the negative sign so that it will become negative 9.5 log over OH. And this time, and just like before, we will make it 10 to the power of negative 9.5 is equal to OH. So OH should be equal to 10 to the power of negative 9.5. Yep. 3.16 times 10 to the power of negative 10, which is equal to this one.
So for item number 3, as you can see here, there's no hydrogen and power of hydrogen and power of hydroxide. We're gonna find those three. So first, we're gonna go with hydrogen. The formula for that would be Kw is equal to 1.0 times 10 to the power of negative 14. So what we're gonna do is put this at Kw and oh wait, it's gonna be like this. Kw is equals to hydrogen multiplied by hydroxide, OH negative. Since we're looking for hydrogen, we're gonna put the number of hydroxide, which is in here. So it's gonna be, oh, we're also gonna put this here. So it's gonna be 1.00 times 10 to the power of negative 14. And we're gonna divide this with hydroxide. So it's gonna be like this. The number of hydroxide, which is 2.1 times 10 to the power of negative 3. So if we input that in a calculator, it's gonna be 1.00 times 10 to the power of negative 14 divided to 2.1 times 10 to the power of negative 3, and we're gonna have 4.76 with it. 4.76, and copy this times 10 to the power of negative 12 as it's shown here, and we're gonna put 4.76 times 10 to the power of negative 12. So now, since we have hydrogen here, what we're looking for now would be the power of hydrogen and the power of hydroxide. So the formula is right here. This is the formula, which is pH is equals to negative log hydrogen, since we're gonna look for hydrogen first. Hydrogen positive. So how we input this is pH is equal to negative log, where's your hydrogen? That's your hydrogen over there, so you're gonna copy this. 4.76 times 10 to the power of negative 12. So you input that in the calculator, which would be negative log 4.76 times 10 to the power of negative 12, and we're gonna have 11.32. So put this right here, write it down. As you can see in the calculator, that's the result. So you're gonna write 11.32 over here, and that's how you get your power of hydrogen in this one. So now, since we only have power of hydroxide remaining here, let's find hydroxide. So what we're gonna do now is actually very similar to this one, to hydrogen. Instead, it's gonna be hydroxide. Since we have hydroxide here, this is gonna be the replacement for this one. So it's gonna be pH is equal to negative log multiplied to hydroxide negative. So what's gonna happen here, we're gonna copy hydroxide here. As you can see, 2.1 times 10 to the power of negative 3. So you input this in the calculator, same as this one, but using the hydroxide. So it's negative log multiplied to 2.1 times 10 to the power of negative 3. You're gonna get 2.6. Since we have three numbers here that can be rounded off, so that's gonna be 2.7. 2 pH 2.7. So how do we know if we got the correct answer? You're just gonna add 11.32 plus 2.7, and we're gonna get 14. So that's how we get the correct answer. So the answer here would be 2.7, and this would be a base, since your power of hydrogen is much more bigger So for item number 4, as you can see, we have 3 blanks missing, which is the power of hydrogen, hydroxide, and our hydrogen. So what we're gonna do first is solve the easiest, which is the power of hydrogen. So what we're gonna do is 14, which is the value of this both to be neutral. We're gonna minus it with the power of hydroxide, which is 8.10, and what we're gonna get is 5.9. Now you might be asking why it's 5.9. Well, if you add 5.9 and 8.10, you're gonna get 14. Okay, now that we're done there, let's go find hydroxide. So how do we find hydroxide? Well, the solution is like this. POH is equal to negative log multiplied to our hydroxide, negative. So we do that since we're gonna find the hydroxide. We're gonna use the 8.10 here since this is the POH. So 8.10 is equal to negative log multiplied by hydroxide. So what we want to do here is get rid of the negative log. To get rid of the negative, we're gonna transfer the minus sign here, so it's gonna be negative 8.10 instead, with positive log multiplied to hydroxide, negative. And now we're gonna put that in the calculator. So it's gonna be shift log negative 8.10. Now this is gonna be a bit tricky for some of you guys, and we're gonna equal that, so we get 7.94. So it's gonna be 7.94 times 10 to the power of negative 9 is equal to our hydroxide rather. Hydroxide. And that's how you get the hydroxide. So it's gonna be 7.94 times 10 to the power of negative 9. So now, as for the hydrogen, it's gonna be the same process, which would be Kw. As you can see here, we have a Kw here. Kw is equal to hydrogen positive multiplied to our hydroxide negative. Since we don't have our hydrogen yet, we're gonna do with the hydroxide. So it's gonna be it's gonna be 1.00, as that's for the given for the water ionic, this is Kw, times 10 to the power of negative 14. We're gonna divide it with our hydroxide, which is 7.94 times 10 to the power of negative 9. So how do we put that? It's gonna be 1.00 times 10 to the power of negative 14, and then we divide that with 7.94 times 10 to the power of negative 9. So what we're gonna get is 1.25 times 10 to the power of negative 6. So It's gonna be put here 1.25 times 10 to the power of negative 6. Since this is not balanced, as you can see, the power of hydrogen is much more smaller than the power of hydroxide. So this classification, it is acidic.